This diagram illustrates the fact that the problem of describing a tournament is equivalent to the problem of allocating medals. Okay, so here we're imagining a tournament of 5 players, A to E, and so we make 10 medals. 10 is 5 choose 2. For every pair of players we have a medal. So for example, for C and D we have this medal here which says C versus D on it, and for A versus E we've got the A versus E medal here. And then so to describe the results of the tournament we just have to say who gets every medal. Okay, so here player A wins every match, and so they get so player A gets these 4 medals: A versus B, A versus C, A versus D, A versus E. B loses every match and so doesn't get any medals at all. C beats B, D, and E, so you get so in this row we get 3 medals for C: B versus C, C versus D, and C versus E. Okay. Yeah, and if we want, we can change the tournament. So changing the score, changing the results of various matches just moves the medals around. Okay. Okay. But notice, there's a kind of constraint on how we allocate the medals. This medal is the A versus B medal. That can only go in A's row or B's row. It can't go in any other row. Similarly, if we look at the A versus C medal, that can only go in A's row or C's row. So to describe a tournament, we just have to describe where the medals go, but subject just to this constraint that every medal, there's only 2 rows that it can go in, corresponding to the 2 names that are written on the medal. And then if we know what scores we want, then we just have to make sure that we put that number of medals in the corresponding row. Right? If we want E to have a score of 4, then we have to organize our allocation of medals in such a way that there's 4 medals in row E.